For the next couple of classes, we're going to be factoring polynomials, and I know that you know how to solve polynomials once they're in factored form, or at least hopefully you do from the last lesson. But today we're going to talk about how to actually create that factored form. And the first type of factoring that we're going to do is using the GCF, or as we know it, the greatest common factor. And factoring is when you write a polynomial as a product of its factors. When the terms of a polynomial have a common factor, you can factor that as shown below. So here are the steps. They might sound absolutely ridiculous to you. You might have no clue what it means, but hopefully you will after we do a few examples. The first thing you want to do when you're factoring a polynomial is to find the greatest common factor of the terms. That includes the coefficients and the variables themselves. Once you do that, you use the distributive property to write it as a product of its factors. And I'll show you how to get that factored leftover piece. So here we go, letter A. We've got this polynomial and we want to factor it. So you look at your coefficients, which are 2 and 18, and you say, what is the greatest common factor of 2 and 18? Well, the answer is 2. 2 goes into 2 and 2 goes into 18, and that's the biggest one. So first thing that I'm going to do is I'm going to divide each term by 2. And then you say, well, do they have any variables in common? This has x squared, but this has no variables at all. So they don't have any variables in common. So 2 is the best that you can factor by. So what do you get when you divide everything by 2? Well, 2x squared divided by 2 is just 1x squared. And if you wanted to write just regular x squared without the 1, you can. And then 18 divided by 2 is going to be 9. What you want to do is you want to put that in parentheses and then put the 2 that you just had right here outside the parentheses. And this is factored form. 2 times x squared plus 9 is the factored version of 2x squared plus 18. And you can check that by multiplying it back. You can say, well, 2 times 1x squared is 2x squared. And 2 times 9 is 18. And you see you get the same thing as you started with. So you should always check your factored form if you're ever not sure, even if you just want to make sure that you have the right answer. Now let's look at one where we have both coefficients and variables in common. So 15 and 10, you want to look at your coefficients first and say what number do they both have in common. The greatest common factor of that is 5. Now you look at your variables, and this has y cubed in it, and this has y squared in it. So here's how you know what the greatest common factor of them is the greatest common factor of variables is always the smallest exponent. So I've written that down for you right here so that when we do our GCF, we always remember that when we do variables, we look for the smallest exponent. So this has an exponent of 3, and this has an exponent of 2. So that means that the smaller one is going to be my GCF. So y squared is also being part of my factor. So once you've done both of those, then you do your division. 15 y third divided by 5y squared is 3y, because you subtract the exponents. And then 10 divided by 5 is 2. And then the y squared divided by y squared, they just cancel out, right? So I'm going to put that in parentheses. And then this piece that was right outside, 5y squared, goes out front. And that's how you write it in factored form. Example 2 asks us to factor and then solve. And remember what we learned last lesson is that if we have the zero product property, we can set the pieces equal to 0. But before you do that, you have to collect the terms on one side. So you have to make them all go on one side together so that the other side of the equation is 0. So as we've done back in chapter 1, I'm just going to drop a line, and I'm going to move the 6g over to the left. That way, these cancel and I have 0. So you're always trying to get a 0 when you want to solve. You can't combine them, so you just have 4g squared plus 6g. Okay. Now, I'm going to step aside from the 0 for a second and just look at the left side of the equation and factor that. And then once it's factored, I can split it up and do the zero product property. So 4 and 6, what factor do they both have in common? The greatest common factor of 4 and 6 is 2. And then how many variables do they have in common? Well, remember, I just told you that you always pick the smallest exponent. So if that exponent is 1 and the other has an exponent of 2, then you use the exponent of 1. So now we have to divide. 4g squared divided by 2g is 2g. 6g divided by 2g is 3. Put that in parentheses, and then bring down the 2g from earlier. And then don't forget, now we're actually going to incorporate that equals 0 part. So we can use the zero product property that we learned last time. So either 2g equals 0 or 2g plus 3 equals 0. So if the first one is true, then that means that g is 0. So that's one possible answer. 2g plus 3, let me do some inverses. That means that g is negative 3 halves. So these are my two possible answers for g. Letter B, if you want to, try it on your own. If not, follow along. So I'll drop a line, and this time I'll move it to the right. So minus 18y. It doesn't matter which side you go to. Okay, now I look at my coefficients and I say, what do they both have in common? I can divide them both by 6, and I can divide them both by y, because that's the smallest exponent. So that gives me 1y minus 3. And then I'll bring that 6y outside. And now I'll bring down the part where it said equals 0, so I can split it down and solve it. So for this one, y would be 0 in order to make that true. In order to make this true, y would have to be 3. So those are my two possible answers. All right, last one together, example 3. A female athlete tests her vertical jump by jumping straight into the air. Her height in feet after t seconds can be modeled by this polynomial. How many seconds is she in the air? So we're looking for a value of t. Now that must mean that we know the value of y. So think about it logically. If y stands for the number of feet, how many feet is she at the beginning? 0. She hasn't gone any feet into the air. When she's done jumping, her feet is also 0. Her value for y is also 0 because she is now back on the ground. So every single time she's on the ground, her y value is going to be 0. So if I want to figure out the time from start to finish, starting is at 0 and ending is at 0, then I can plug 0 in for y and get those two values and figure out the difference between her starting and ending value. So let's take our polynomial and plug in 0. I have to factor it, and if you have a negative leading coefficient, it's called a leading coefficient when it's the largest exponent value, like in standard form, that's negative. When your leading coefficient is negative, you should pull out a negative, so that way your leading coefficient now is positive. So I have to figure out what I can pull out from a 16 and a 12. and the answer is 4, so I'll pull out a negative 4, so that way this leading coefficient is positive. Now, if you don't pull out a negative 4, that's okay. It will just be a little trickier with your signs. Now I need to look for the exponent that I can pull out, or the variable term. So this is t squared, and this is t to the first. So I can pull out a t to the first, or just t. So now I get, and really you should divide over here as well, but 0 divided by anything is just 0, so it doesn't change its value. So I get 4t, hold on, I get 4t minus 3, and then that goes in parentheses. Don't forget to put what you pulled out front. So negative 4t goes out front. It doesn't go away, it just gets put in front. You're kind of reverse distributing, because you can check yourself by distributing this, and you should get negative 16t squared plus 12t. If you didn't have this negative 4t out front, then you wouldn't get the original polynomial back, because the 4t would have disappeared. So you should always make sure that you put that out front. And I'm sorry my writing is a little sloppy. So now I drop a line and I solve each piece for 0. So one side is negative 4t equals 0, and the other one is 4t minus 3 equals 0. So when you solve this left piece, I'll just cut right to the chase. This is t equals 0, and this is t equals 0.75. So let's answer the question. How many seconds is she on the ground? So she starts at time of 0, so like that would be when you first start your stopwatch, and then 0.75 seconds later, she's back on the ground. So the distance between 0 and 0.75 is 0.75 seconds. It's kind of like when we did that fireplace question, where we had to find the distance between the two values. So the distance between her starting value and her ending value is 0.75 seconds. If you have any questions, write them down and ask me when you come to class.